In this video, we're going to continue topic 5.4, where we are looking at relative extrema. We're going to consider the function m prime of x, where the derivative of m is defined as m prime of x equals 2 cosine x plus 3. Find any values of x where m of x has a local extremum on 0 to 2 pi. So we are definitely working with some trig here. I know I'm going to start the same way. I'm going to set my derivative equal to 0. The good news is they already gave me the derivative. So I've got 2 cosine of x equals negative square root of 3, and cosine of x equals negative square root of 3 over 2. So I am going to look around my unit circle for anywhere where the cosine is negative square root of 3 over 2 to find my critical numbers. I know cosine is negative in quadrant 2 and quadrant 3. So I'm going to look at these values here. I know that this coordinate is negative 1, 0. So I count up 1, 2, 3, down 1, 2, 3. From here, 1, 2, 3, 1, 2, 3. So I know that I'm looking for cosine the x value. So I'm looking here, negative square root of 3 over 2. And negative square root of 3 over 2. So I just have to figure out what radian measures those are. So I know that this has got to be, let's see, that's a pi over 6. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi over 6. And then this is 6 pi over 6, 7 pi over 6. So it's 5 pi over 6 and 7 pi over 6. So x equals 5 pi over 6 and 7 pi over 6. All right, so let's put those in our sign chart. So I've got my intervals. I know I'm starting at 0. My first radian measure is, or my first critical number is 5 pi over 6. My second one's 7 pi over 6. And then we know we are ending at pi, or at 2 pi. All right, I'm going to pick some x value, or some, yes, we're in x values. I'm going to try to determine what's going on with m prime, because it's m this time. And then we're going to look at, and we're supposed to be looking for local extrema. That's popping up. And so we're going to look at what's going on with m. All right, so something that's in between here, I could pick, let's say just, let's do 3 pi, or let's see. Let's do pi over 3 pi over 4, which would be like right in here. Okay. In between these two, I'm just going to say pi. And then, I don't know, I'm going to go 3 pi over 2. That's one of our axes. So as long as I'm in there. So 3 pi over 4. If I think about what's going in there, and I'm going to go into my most simplified form of the derivative, which would actually just be this original form of the derivative here. Okay. So my cosine of 3 pi over 4, I think about that. Actually, I'm going to change this up. I'm going to say that this is at pi over 2. Okay. So I know at pi over 2, my coordinates are negative 1, 0. That's going to make my life a whole lot easier. So negative 1 is what we would substitute in for this piece here. So we're really doing 2 cosine of pi over 2 plus square root of 3. And all I care about is the sign. I know the cosine of pi over 2 is not negative 1. It's positive 1. No, it's not. It's 0. This should be 0, 1. So 0, that's going to zero this out, meaning this is a positive. Looking at pi. Cosine, let's change to a different color. Let's go to green. Let's go to purpley. So we're looking at pi. Ooh, don't know what's going on. Pi. So the cosine value is negative. So whenever I plug the cosine value into there, so 2 cosine of pi plus square root of 3. This is negative 1. Okay, so I've got negative 2 plus the square root of 3. Well, I know the square root of 3. Just if I know the square root of 4 has got to be 2. So the square root of 3 has to be less than that. So it's like 1 point something, meaning the negative 2 is going to win the sign war. So it's going to be negative. All right, and then finally 3 pi over 2 I know is 0, negative 1, meaning my cosine value is going to be 0. So I'm just doing some scratch work. 2 cosine of 3 pi over 2 plus square root of 3. I know that's going to zero out, so I get a positive. So I am increasing, decreasing, increasing, meaning I go up, go down, go down, go up. So it says find any max values of local extrema. So I'm going to write those in sentences. So F has, this is a max, and this one's a min. It says local, so I'm going to use the word local. Has local max at x equals 5 pi over 6 because m prime changes from positive to negative at this value, or at this point. Okay, F has a local min at x equals 7 pi over 6 because m prime changes. Again, I could read this right out of here. From negative to positive at this point, or at there, it works too.